In this sequence of videos, we're going to discuss exponential functions. Let's talk a little bit about the main ideas of this topic. But before I do that, I want to make an observation about a simpler type of function, the linear function. So let's say we have a linear function, f of x equals, and I'm just going to make one up, 5x minus 2. These linear functions have the property that if you change the x value by 1, the y value changes by a specific amount every time. Let's make a table so we can see that. So f of x, we start at x equals, let's do 0, 1, 2, 3, and I think I'll be able to convince you of the pattern after that amount of x values. So negative 2, 5 times 1 minus 2, that would be 3. 5 times 2 is 10, 10 minus 2 would be 8. And 5 times 3 is 15, 15 minus 2 is 13. And so you see, as we increase by 1 the x value, the difference in the y values is always 5. And the important thing here to note is that the change in the y value is always the same. There are a lot of great applications of linear functions. Let's take, for example, if you know your speed is equal to, let's say, 10 miles per hour, then between each hour, you will travel a distance of 10 miles. So the distance traveled in 1 hour is always 10. So if you know your speed, and it is constant, then the distance traveled will be a linear function. Exponential functions are a little different. So let's go back and revisit our table. So when we increased the x value, the y value always increased, or linear functions can also decrease, but in our example, the linear function increased by a set amount every time. With exponential functions, the situation is a little different. The increase, as you increase x by 1, is based on some percentage of the previous y value. And depending on the context, this percentage might be expressed as a fraction of the previous y value. To make things a little clearer, let's talk about a very simple example. Let's suppose that someone gets sick with a new virus. So on day 0, we have 1 person sick. Let's go ahead and call f of x the number of sick people on day x. And let's also assume that on each day, if you are sick, you infect 1 person. So each sick person infects 1 new person per day. Let's go ahead and make a table and see if we can identify any pattern with the number of sick people. So on day 0, when x is 0, there will be 1 sick person. What about on day 1? Well, there was 1 sick person the previous day, and they infected another person. So now there's 2 sick people. Okay, what about on day 2? Well, on the previous day, there were 2 sick people. So each one of those sick people will infect a new person. So that means that there will be 4. What about on day 3? Well, there are 4 sick people the day before. So these 4 sick people will infect 4 new people. And so we'll get 8 sick people. And on day 4, we'll get 16. And the important thing to notice here is that the change between 2 y values is a number times the previous y value. So the number here happens to be 2, but depending on the circumstance, you might have a different number there. So 2 times the previous y value is the new y value. And if we contrast that to what we had before we had that the difference between each y value was the same if you increased the x value by 1. Whereas here, the difference between each y value is not the same. The way that you get a new y value if you the way that you get a new y value if you increase the x value by 1 is you have to multiply the previous y value by some number, and in this case it's 2. And if 2 was a different number, then we would have a different exponential function. More details on that to come, but the important thing to note here is that when you have a model or a function and the change in the y value is proportional to the y value, you will have an exponential function. Whereas if you have some model where the change in the y value is the same as you increase the x value by 1, you'll have a linear model.